Hello AP Statistics. In this video, we're still in Unit 1 and we are talking about more specific measures of center and spread for quantitative data. So we're going to get a lot more specific in this video than we have in our other ones. So when we talk about the measures of center, there are two common measures of center that we are going to deal with in AP Statistics. We're going to talk about the mean, and we're also going to talk about the median. Now, you're probably already familiar with these terms. The big thing I want you to pick up on here is the idea that when we're finding the mean of values, we are making a calculation. We are adding those values together and dividing by how many there are. When we're talking about the median, it's actually a physical middle of our numbers when they're in order based on lowest to greatest or greatest to lowest. So keep in mind that the mean is a calculated value and the median is a physical value. Okay, so that's going to help us here in a minute. So I also want to address in this video this idea of a statistic versus a parameter. Now I want you to notice in my definition here, a statistic is a number and a parameter is a number, but they describe different things. Notice that a statistic describes a characteristic of a sample and a parameter describes a characteristic of a population. So what's the difference? Well, think of the population as all AP students in Texas. Okay, that's the group I'm interested in because I'm in Texas. A sample would be my classes. Okay, so clearly the sample is much smaller than the population. All AP students in Texas. I don't teach all AP students in Texas, but that's my population, and if I want to create a sample, I'm just going to use my classes. So if I were to take your Unit 1 test, for example, and average up the grades, I'm going to come up with a class average for my classes. That average is going to be my sample statistic. An estimate of the Unit 1 average for all AP students in Texas would be a parameter because those numbers are impossible for me to get. Okay, so that's why I said an estimate of the population parameter. All right, so moving on to this idea of a statistical measure being resistant. What does resistant mean? So we're getting back to this idea of mean and median now. Mean and median are present in every set of numbers. Let me show you what I'm talking about. I've got some data put into Statplet. Okay, I've got test scores here. I've got test scores for Group A and test scores for Group B. Notice that all of the test scores are the same except the lowest one. In test group A, I've got a 75 as the lowest grade. In test group B, I've got a 40. When I begin my analysis, I want you to notice down here that there's a summary statistic area, this little table down here. I've got 5 sets of tests in each group. They each have a mean, they each have a standard deviation, minimum, Q1, median, Q3, and max. So every set of numbers has both a mean and a median value, but based on the shape of the graph, one of them gives a better indication of the overall center of the data. Let me show you what I'm talking about. When you look at let's look at the histograms. When you look at the histograms for these two sets of grades, in this top histogram, my lowest grade was a 75. In this bottom histogram, my lowest grade was a 40. Notice the gap. But I also want you to notice that 4 out of 5 of these test grades were between 80 and 100. So that is a better representation because this 40 down here is going to make the mean much lower than the median. I want you to look down here at my summary statistics. The median is an 84 for both sets of data, but the mean in Group A is 85.6, whereas the mean in Group B is 78.6. That's because that 40 got calculated, see, and there's a big gap between 40 and the next lowest score. Therefore, if I'm going to report a measure of center, I want to report a measure of center that more clearly indicates what the center is of the majority of the data, not just one individual. Therefore, in this second group of data, it would make more sense to report the median as the center because it's more representative of this large set of data, or this larger set of data. Okay, so what does that mean? Well, here's what it means. The mean is not resistant to extreme values, because when you take those 5 test grades and you add them together and divide by 5, you find that when you have an extreme value like that 40 is in there, it's going to drastically lower the mean. If you have a low value, the mean will follow it. It will be lower than the median. So it's not resistant to extreme measures. The median, however, remember our picture over here, remember that the medians were the same. They were both 84. That indicates to me that no matter what my extreme values are doing, my median is going to stay put. It is resisting that low value of 40. So the median is said to be resistant. All right, so now let's talk about measures of spread. A measure of spread measures the variability. The range is the most simplistic value for the spread that we can use. It just subtracts the minimum from the maximum. The range is what we report when we only have a graph and we don't have the data and we don't have the means to calculate the mean and median, IQR, and standard deviation. But if we do have the data, or we have a summary statistic situation, we can calculate or be given the standard deviation or the IQR, and the IQR. These are both measures of spread, just like mean and median are measures of center. So how do we know when to use what? Well, we base that on shape. So we choose an appropriate measure of center and variability to report based on the shape of our distribution. If you've got something that's nice and symmetric, you're going to report the mean as the measure of center, and you are going to report the standard deviation as the measure of spread or variability. If you have something that is weird, something that is not symmetric, like something that's skewed right, something that's skewed left, any of these, well, that means that you're going to report the median as the measure of center. And keep in mind, when in doubt, all right, if you've got a set of data that it looks like it might be a little right skewed, but it's mostly symmetric and you can't really decide, it could go either way. It doesn't matter which way you go, as long as whatever shape you're reporting, you choose the correct measure of center and spread. So the measure of the IQR is the measure of spread when you choose median. Now here's what you have to remember. Mean and standard deviation always go together. Median and IQR always go together. You're never going to report the mean with the IQR or the median with the standard deviation. These two go together and they never break apart. All right, so I want you to notice that this is the formula for standard deviation. You're never going to have to use this, and I'm never going to make you memorize it. It's going to be on your formula chart, etc., etc. So your formula for standard deviation looks like this. Notice that it is a formula, therefore it is a calculation. That means regardless of how spread out your data is, you are going to be calculating each value's distance from the mean and calculating this standard deviation. So this value is very, very, very non-resistant, just like the mean is. But it is even more non-resistant because now it's calculating all those distances away from the center. So we would not want to use standard deviation if we have skewed data or something with extreme values. Okay, that is why we stick with symmetric for the mean and standard deviation. All right, the measure for the IQR. The IQR measures, it takes the first and third quartiles of your distribution and it subtracts them. Why is this important? Well, I'm going to go back to my graph here, and I want you to notice something. Notice that the Q1 in your summary statistics is 77.5 for Group A, and it's 60 for Group B. For Group A, the Q3 is 94.5, and the Q3 for Group B is 94.5 as well. If we're taking the difference of those values, I want you to notice that the Q1 in Group B, despite the fact that we have a minimum of 40, the Q1 is 60, which is much higher than 40. See, it's focusing in on the middle 50% of your data, and it's not taking into account those extreme values that might occur on either side. So again, this value, the interquartile range and the median, so the IQR and median, are resistant. They are resistant to extreme measures. Therefore, those are going to be your choice when you're choosing to report center and spread for anything with extreme values.